Hey, Shopping Alliance Math Industry, and we are going to look at the discriminant. So, we've been doing a lot of work with the quadratic formula, and while we're going to learn about the discriminant, what we're going to understand is we've been working a lot with the formula in the past, and in the previous videos, we've learned that every time you look at the square root, it's going to dictate what kind of answer you will get when finding two x variables in a quadratic standard form equation. So when using the quadratic formula, you're going to have two numbers that represent x, or the x-intercepts when you graph them on a graph. But before you even know the answer, and when you're working on the quadratic formula, we can use and look at the square roots. But what happens if you don't want to do the quadratic formula just yet? What happens if you want to try and find what kind of answer you're going to get without plugging the numbers into the formula? That is why we are going to look at the discriminant. So what we were learning in the past, in the last video, that we learned that when we have a square root of a positive number, like a perfect square like square root 16, or the square root of 3, we're going to get two solutions. They could be rational if they're a positive number, or irrational if they're a number that is not a perfect square. So we can get two solutions. One that's irrationals, or twos that are also irrational, one or the other. If a square root is the square root of 0, that is, the square root of 0 is equal to 0, we're going to get one solution. So that means when doing the quadratic formula and your square is the square root of 0 equal to 0, you'll get one solution. It could be rational or irrational. And the final one is theoretically not possible at the moment. But we can when we get to higher level math. When your square root becomes a negative, that means there is no real solution. We can solve it by using a letter I, but that is at higher level math. We'll learn about that a bit later. So if you have a negative square root, we're going to say just for now that there's no real solution, because the word imaginary means you're pretending to add something into your answer. So that's for a bit later.
We don't need television. Not as long as we have our imagination. With imagination, I can be anything I want. A pirate. Arr. A football player. Hup.
A starfish!
Patrick, you're already a starfish.
See, Squidward, it works!
The noises! How are you two making those noises?
Oh, that's easy. All you need is a box.
And imagination.
Are you trying to say
So we've been learning why the square root dictates the entire formula. But there is a formula called the discriminant that we can understand and learn without having to use the square root. This formula will help you plug in all of your A, B, and C values into the formula and determine what kind of answer it is without having to even touch the quadratic formula. So, here are the scenarios. If your answer for the formula, because D represents the discriminant, if your number is greater than 0, that means your parabola or your quadratic standard form will be having two solutions, whether it's irrational or rational. And what it would look like is going to have two x-intercepts on the graph. The second scenario is when your answer that you get from the formula is equal to 0. That means that'll give you one solution. It will be both one rational number or one irrational number. So there's one solution. That happens when your number exactly equals 0. And it means that your vertex or your end of your parabola is touching the x-axis, but it's the vertex. And finally, if your answer is less than 0, that'll give you no solution. Because what we said earlier in this video, that you can never, ever, 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 ever have a negative square root. Because right now it's not possible. So if you have any negative numbers that represent d or less than 0, it's no solution. And that also means that nothing strikes through the x-axis. We're trying to find two variables that touch the x-axis and represent the x-intercepts. But in a no solution, the parabola will never, ever, ever touch the x-interceptor, touch the x-axis. Because here's the example. So those are the scenarios that will happen when you try out the formula. Let's actually release the formula. Here is the ultimate reveal. The test formula that we're going to be using is d is going to equal b squared minus 4ac. The reason why we use this formula, because going back to the quadratic formula, it looks like that b squared minus 4ac is just right here in the quadratic formula of the square root of b squared minus 4ac. So basically, the test formula that we're going to do determines what kind of square root it is. Here's an example. If you do the quadratic formula, and let's say you get an answer, or square root of 16, without having to do the actual quadratic formula, we can plug it in right here, and you would still get d equals 16. That means that it's the same thing as the square root of d. So whatever you get in the discriminant test formula, when you insert your a, b, and c value, it's going to represent d. And that is telling that it's the square root of d when you get the square root of 16 when working on the actual formula. Let's do a scenario. So here's the scenario. We have to see what kind of answer we will be getting for this without touching the quadratic formula. So we have to do, our a value is going to equal 2. Our b value is going to equal negative 3. And finally, our c value is going to represent 4. What we're going to do is plug these into this. So we're going to have d is going to equal negative 3 squared minus the 4, multiply that by 2 because of a, and multiply that by 4 because of c. Let's see what happens. So negative 3 squared is 9. We minus that by 4 times 2 is 8. Multiplied by 4 is 32. So 9 minus 32 is going to be a negative 23. But uh-oh, there's a problem. That d that we're going to get represents the square root of d. And if we take a look back at the scenarios, if our answer of D is less than 0, that means it's a no solution. So if negative 23 is our D, and the square root of negative 23 is something we try to work on, we actually can't do that because there's actually no solution. We can actually prove it by, well, not prove it. Another example is actually doing the quadratic formula. So we rewrote the formula. We also plugged into the numbers. We simplified. Oh, here it comes. Here's where we start seeing things. And here it actually comes. The negative 23 right here. The square root of negative 23. That means there's no real solution. So without having to do all this work, we could just find the discriminant and get what D is and use the scenarios to discover what kind of solutions we'll get. This formula is very helpful for finding the solutions to a quadratic trinomial, but it's not going to help you actually get to the answer. Like, it's not going to help you get to x equals 1 or x equals negative 3, or it's not going to help you get to no solution or no real solutions. It's going to help you get to what kind of solution, but not what solutions, like x equals. I hope this video has helped you. Thank you for watching How Penalize Math Industry. Like and subscribe. And if you want to try and do this experiment on your own, try and come up with creative quadratic formulas. Well, not quadratic formulas. Try to come up with creative quadratic trinomials and see what you get for D. And try to use the different scenarios to see what you will get. Like and subscribe.